Go to the all right. So last time I have promised to give you some activities for the clustering algorithm, k-means clustering, but I believe I have not given it to you just yet. So probably after this meeting, I will be giving you that assignment and also assignment for this topic. So this topic is a new one. We're going to discuss a new topic for this session and a continuation of this session for the next session. So I think you already know the pattern, how I am teaching you this group of learners for this class, that I follow up the learnings for the next session. So going back to the topic on session 6. So on session 6, or probably session, where's that? Here on session 5, we were talking about the different analytics in data science. We talked about descriptive analytics. So a little recap. Descriptive analytics is more of the visualizations. We get the information, or we get data, or we mine information, we mine data via descriptive analytics using visualization and observations. Now, we move on to predictive analytics. This was session 5, I believe, around session 6. Around session, I guess, session 6, all over to session 7. Yeah, I believe so. That is we are predicting the clusters of our data. So still, we are on the predictive analytics. Today, our topic is still on predictive analytics, but in a different spectrum. Okay, so what I'm saying is that analytics is connected with the different kinds of learning with respect to the machine. And this is a very cool explanation of the different kinds of learning when we are talking about predictive analytics. So in predictive analytics, we are going inside machine learning, the topic of machine learning, and we're talking about supervised, unsupervised, reinforcement, and generative learning. So let me give you short examples of this one. Supervised learning is we get the right answer, and that is the topic for today. Unsupervised learning is we group similar things. This was the previous topic, what we did in the k-means clustering. We are practically using unsupervised learning last time. And then there is another learning which is a more advanced topic from the first two. The first two is supervised and unsupervised learning. Once you master supervised and unsupervised learning, you can proceed to reinforcement learning. So this reinforcement learning is learning by doing. Basically, let's say the machine does not know anything in regards to the problem or regards to the what is the answer. It's just going to learn by itself, or it's just going to explore. So that's reinforcement learning. And also, in reinforcement learning, what happens is that the computer or the machine is rewarded. When the computer is rewarded, it reinforces the learning. So it only focuses on a bigger reward than the smaller reward. So reinforcement learning is not knowing the answer, but getting the most beneficial from the different steps. So that's reinforcement learning. So in real world, this is happening on experiments. Let's say you want to create an AI that will answer a simple puzzle. Of course, knowing the answer to a puzzle is tedious, and we don't want to answer that because a puzzle will consume a lot of time. What we want for the AI to do is, even if we don't supply it with answer, the computer or the machine will try its best to answer it based on the reward it gets. So that is reinforcement learning. And nowadays, the most popular of the four machine learning technologies is the generative. Have you heard the concept GPT? Narinig niyo na ba ang GPT? Or does it ring a bell? Narinig niyo na ang GPT. Usually, ano ang karugtong ng GPT? GPT-4. Okay, sige. Okay. Okay na yun sa akin. Actually, before I spill the bean, what is the meaning of GPT? Does anyone know what's the meaning of GPT? Oops! Nag-Google na. Pero okay lang yun. If you don't know, GPT stands for Generative Pre-trained Transformer. Tama ba? Pre-trained transformer. Ayan. So, nagtataka ba kayo or hindi niyo ba question bakit gano'n yung pangalan niya? So, the generative pre-trained transformer is actually an iteration from the different generative learning algorithms. So it started with GAN. It started with the concept of GAN. So GAN is what they call generative adversarial networks. So nagsimula naman yung generative adversarial networks na yan sa mga artificial neural networks or ANN. Nagsimula yung generative adversarial networks na yan because of the artificial neural networks. So neural networks is actually not foreign. It's not actually foreign for us because according to the inventor of the artificial neural network, it came from the idea of the human brain. the human brain has has many neurons, and this is actually what makes our brain. Many neurons, and these neurons are like the cells of our brain, and this nagfa-fire yung neuron natin every time na nakaka-experience tayo ng isang bagay. So, have you ever wondered, when you do the things that you do every day, you master them? So, ulitin natin yun. When you do the things you do every day, you master them. Okay, when you do the things you do every day, you master them. Okay, so meron din akong narinig na in order for you to learn something, you need to invest 20 hours practicing or doing that that work or something. So you need 20 hours. And if you want to master something, you need 10,000 hours to really master it. Maybe the 10,000 hours is just hypothetical, but if you get the idea, learning is by means of practice. Anything that you are a beginner, most likely, you will fail to do that task, to do that work. So in order for you to do the task flawlessly or efficiently, you really need to practice doing it. Just like in work. Kapag nagtatrabaho tayo, the most of the time, every day, kung ano yung ginagawa natin, na ma-master na natin, we tend to memorize what we're doing almost every day, and basically that's how neurons work in our brains. Whenever you practice, experience it, it's wiring inside our head and creating neurons, making us remember and be master of that task. So ginawa ng mga scientists, they also copied or mimic. It's basically a scientific theory. It doesn't really mean na ganun talaga yung ginagawa ng brain natin. It mimics only. So using mathematics, they try to create computations that mimic the human brain's how it learns based on artificial neural networks. So, nagsimula lahat yan sa neural networks. And yung neural networks, nagsimula siya sa mga basic algorithms na matututunan natin today, such as decision tree. Okay? And also, yung natutunan natin last time, K-means clustering. Ano yun? Component pa rin yun ng neural networks. So evolution lang to, actually guys. Evolution lang siya. Why we are trying to learn the simple algorithms such as the K-means clustering algorithm and the decision tree algorithm? Because without the fundamental knowledge of this one, it is very heavy to digest the concept of neural networks. That's a very, very advanced data science concept. So, yun lang naman ngayon, where different types of learning exist. And basically, what we are doing today is supervised learning. Yeah, so supervised learning is what we're going to do today. So supervised learning, let us explain further. Supervised learning is a type of machine learning in which the model is trained on a labeled data. So our data here should be labeled, or in simple saying, the data that we're going to provide to the machine algorithm should have label or answer. No? So the label data refers to the data that's already been classified or tagged with the correct output. The goal of the supervised learning is to learn a mapping between input features and output labels so that the model can make predictions on new unseen data. For example, a spam filter and an input feature might be the text or an email. So kapag mga mga possible case study to do supervised learning is the classification of a spam. So yung spam na-encounter natin to sa mga email natin, especially yung mga nagfi-fish ng information sa atin or tinatawag na phishing. Isa siyang a digital crime na ginagawa ng iba talagang mga tao para makapagnakaw yan. So spam can also fill up our email. So basically this is actually a feature already of our email providers such as Google or Gmail. Dinedetect na nila yung spam. No? So ang ginagamit nila dito is text and email para malaman kung this is a potential spam email or not. So it classifies. So there are two types of supervised learning. We have classification and regression. Classification is like knowing the category of that data instance. Okay? In Tagalog, classification is trying to know where it belongs. Saan ka ba mapupunta? Saan ka ba masisegregate? No? Kina-classify mo siya. Yan. Kasi, una, feed natin sa data yung mga may label. Tapos natututo siya na yun yung mga may classification. And then, pag may pumasok na bagong data, doon natin magagamit yung machine learning na yon to classify kung saan siya mapupunta. And then we have also regression. So regression is more or less prediction. Ano ang ginagamitan ng regression? Usually numerical. Numerical ang regression and classification is categorical. For example, ng classification, you are iris setosa, you are iris virginica, you are iris vesicolor. Or for example, spam or not spam, that's classification. And another example is, can we play outside or can we not play outside? So there are different factors that will tell us if we can play outside. Let's say the feature is it's very hot. Of course, you cannot play outside. So that's classification. More or less categorical siya. And then we have regression. Regression is prediction. The prediction is usually numerical. For instance, what is the predicted house price of this 2-story house with 2 bathrooms and 1 master and 1 living room? So how much is this house? So basically, that's a regression problem because you're going to predict the value of the house. What else? You're going to predict the percentage of the battery. Let's say you're going to predict yung life expectancy ng battery mo based dun sa paggamit mo sa kanya. Ayan. You can also predict the amount of loan, kung anong pwede mong ipaloan sa tao na yon. Ano yung acceptable amount of loan na pwede niyang utangin. So that's a regression problem under the supervised learning. Okay, so another one, we have unsupervised learning. This is what we are actually doing last time. Itong unsupervised learning na to. Because what is the goal of the unsupervised learning? We are getting patterns, discovering patterns, structuring, or the example is clustering. So you might notice na nauna yung unsupervised learning sa supervised learning. Kaya ako inuna yung unsupervised learning sa inyo. Kasi usually yung mga tao, nawiwili sila dito sa supervised learning. Tapos hindi nila na-appreciate yung unsupervised learning. Kaya binaliktad ko sa inyo. Inuna ko yung unsupervised learning, which is clustering, bago ko pumasok dito sa supervised learning, which is classification and regression. Okay. Sa unsupervised learning, there is no classification and regression, but there is clustering. So, ang pagkakaiba ng supervised learning sa unsupervised learning is that in supervised learning, the data is labeled or labeled data. Sa unsupervised learning, the data is unlabeled. Okay? Tinatanggal natin yung, kung mapapansin niyo or maaalala niyo yung zoo dataset, di ba we mask the classification of the animals. Hindi natin nilagay doon kung mammals ba siya or ano siya. Yun, hindi natin nilagay. Ang ginawa natin doon, ginawa natin siyang number-based. Although lahat ng mammals is one, we did not say that they are mammals. No? Yun yung ibig sabihin ng unlabeled data. Usually, unlabeled data may categorical value. Then reinforcement learning, I don't know if we can tackle this one because reinforcement learning should be taught in a separate class. A whole new course, parang ganun. Ang reinforcement learning kasi sobrang bigat ng konsepto na to. Usually tinuturo siya isang course. Ito din, yung generative learning. Ito, tinuturo sila ng separate, itong dalawa. Hindi siya pwedeng ituro basta-basta sa data science, lalo na kung yung composition ng mga tao sa data science is beginner, no? Pag ang composition ng tinuturuan natin sa data science puro beginner, hindi kakayanin yung 4 na concepts into one. Pero ang ibig sabihin lang nito, dapat maintindihan natin na may 4 na machine learning tasks. So yung 4 na machine learning tasks na yun is supervised learning, unsupervised learning, reinforcement learning, and generative learning. And they are all in the umbrella of predictive and sometimes diagnostic analytics. Okay? Ang dami niyo na bakit natin inaaral itong mga to? Kasi under sila ng analytics, under ng predictive and sometimes diagnostic analytics. So, pag inaral natin to, yung clustering at saka yung classification at saka regression, pumapasok na tayo sa mundo ng saan mo yung topic ko? Nandito ba yun sa tuloy? Pumapasok na tayo sa mundo ng ano siya po? Ito. Pagpapasok na tayo sa mundo ng predictive analytics at saka diagnostic analytics. Ayan. So, ang pagkakaiba lang naman ng diagnostic analytics sa predictive analytics. Kasi dito sa predictive, pag na-predict na natin yung classification tsaka regression, inaalam lang natin yung accuracy, kung gaano ka-accurate yung prediction niya, at saka yung kung gaano siya kapangit. Ganun lang. Sa diagnostic analytics, ibig sabihin nun, tapos na tayo sa predictive analytics, na-prove na natin na 99.9% na pipredict natin ng isang bagay or nakaklassify natin ng bagay. Tsaka lang papasok ang diagnostic analytics. Because in this perspective, sa diagnostic analytics, since na-prove na natin na okay yung prediction natin, mataas yung accuracy, alamin na natin kung ano yung nakakapag-define kung bakit yun yung katangian ng outcome natin. Kumbaga, ito yung outcome natin, dapat masagot natin kung bakit yun yung naging outcome. What is the reason that happened? Bakit nangyari yun? So, nangyayari ang diagnostic analytics pagkatapos ng predictive analytics. Sana umabot tayo dito sa diagnostic analytics. Yun. Kasi tingnan lang natin kung nakakalo tayo. Pero yun yung ibig sabihin nun. Usually, nauuna sa lahat ay descriptive analytics, then predictive analytics, then nagkakaroon tayo ng diagnostic analytics. Kadalasan kasi, ang diagnostic, kailangan niya ng scientific proof. Kasi nagda-diagnose ka nga, di ba? Inaalam mo yung sakit niya or yung reason bakit nangyari yun. Ngayon, itong prescriptive analytics, since nalaman mo na yung mga different kinds ng sakit niya, kailangan makakapag-prescribe ka ng action or gagawin niya para ma-meet niya yung goal niya. Kunyari, ang customer mo, mayroon siyang 3 goal. Meron siyang goal 1, goal 2, goal 3. Kailangan makapag-prescribe ka ng nararapat for goal 1, goal 2, and goal 3. Ngayon, itong prescriptive analytics, this comes with experience. The data scientist should be very experienced before providing prescriptive analytics. Okay, so let's go back here. We are still under predictive analytics and we are talking about supervised learning for today. And with that, I'm going to share to you a slide. Papasok tayo sa isang example ng ng unsupervised learning. So this one is decision tree. Okay. Yan. So this is an example of a unsupervised learning algorithm under classification or regression. So either way, ginagamit ang decision tree for classification problem or regression problem. The question is, ano ba yung outcome, no, na gusto natin makita? Pag ang outcome natin is to categorize the missing data or the new inputs, that is classification. And if we wanted to know the numerical value, that is a regression. So decision tree, decision classification tree, pag classification problem. Tapos regression tree ang ginagamit naman kapag numerical ang problema ang hinahanap natin. So we will be discussing what is a decision tree, sample decision tree, how to construct a decision tree, problems with decision trees in gaming, and summary. So what is a decision tree? It's an inductive learning task. Use particular facts to make more generalized conclusions. A predictive model based on branching series of Boolean tests. These smaller Boolean tests are less complex than one large classifier. So a decision tree has a statement, no? May statement siya. Let's say ang statement niya na nakalagay is live at. We have three choices. If we're going to leave at 10 a.m., are we going to be stalled? Or if we're going to leave around 9 a.m., are we going to have an accident? So what if we're going to leave, probably if we leave at 10 a.m., 8 a.m. and 9 a.m., so we will not encounter any stalling around 10 a.m. Ibig sabihin, hindi magta-traffic. Pag 9 a.m. naman tayo, we might experience an accident. Or did we have an accident? Pag nagkaroon tayo ng aksidente, possibly, hahaba yung resulta ng commute natin. That's why, dun sa decision tree, may tatlong statements na kailangan ma-prove ng yes or no. Simple lang naman siya, yes or no. So, if you leave at 10 a.m., na traffic ka ba? Yes, oo. So, long yung outcome ng commuting mo. Pag hindi ka naman na traffic or hindi ka na stall, short lang. Makakadating ka na dun sa pupuntahan. Pero usually, pag umaalis ka ng 8 a.m., according sa decision tree na to, mahaba ang commute. But the reason is not about stalling and accident. Parang, possibly, mahaba lang talaga yung pila. Siguro sa hintayan ng sasakyan, kasi wala pang sasakyan pag 8 a.m. So, possibly, mahaba talaga yung paghihintay. Ayun, so this is how the decision tree works. So this is an easy example. This is an easy example, but decision tree is being used to complex data sets. So in that decision tree, have different series of Boolean decision. Yung mga Boolean decision is, alam niyo naman siguro, pag sinabi natin Boolean, dalawang answer dyan. Yes or no. So, having said that, yung kulay brown, that is a Boolean question. And you need to answer that with true or false or yes or no. So we did not have represent this tree graphically. So we can use this rule set. Pwede tayong gumawa ng rule set para ma-determine natin yung structure ng decision tree. So this is an example of a rule set. Ito, gine-generate to ng ano natin, ng algorithm natin. Okay, yung decision tree result na yan. Nag-generate yan. Ang tawag natin dyan is rule set. Ba't siya tinawag na rule set? Because it's like an if and else statement. Na meron siyang if ganito, ito yung outcome. Else, kung hindi ganon, ano naman yung mangyayari? Ito naman. So if else siya, meaning that is a rule set. So first we make a list of attributes that we can measure. So ang ibig sabihin nito, sometimes we get the attributes or sometimes we download the data set and the attributes are already there. And then we choose a target attribute. Yung target attribute na yun that is the classification label attribute. Naalala niyo kanina, yung sinasabi ko kanina sa discussion ko, label data. Label data, no? Pag sinabi natin label data, that is a supervised machine learning problem and kailangan natin i-select yung target attribute because the target attribute is the label or the answer on our data set. Here is an example. Okay, so we have different examples of instances and the attributes are hour, weather, accident, stall, and then commute. So base dun sa actually ito yung pinanggalingan na dataset nung nagawa nating decision tree na to. So itong decision tree na to, this was derived from this data set. So kaya nga natin siya tinatawag na data science because we're going to get the science or we are going to structure the decision tree, which is science, out from this data. Okay? We will extract the decision, which is science, from this data. That's why what we are learning is called data science. So tandaan niyo lagi, ang supervised learning laging may target attribute at ang target attribute ay dapat or kadalasan categorical siya or text. Categorical or text value. So we are going to choose the attributes. The previous experience decision table showed 4 attributes. Okay, so we have 4. Hour, weather, accident, and stall. But the decision tree only showed us 3 attributes. Hour, accident, and stall. Why is that? Methods for selecting attributes which will be described later, showing that the weather is not a discriminating attribute. We use the principle of Occam's razor. Given a number of competing hypotheses, the simplest one is preferable. So the basic structure of creating the decision tree is the same for the most decision tree algorithms. Ayan. So the difference lies in how to select the attributes for the tree. So we will focus on the ID3 algorithm developed by Ross Kinlan in 1975. So yung ID3 is a variant. This is a variant of a decision tree algorithm. Who developed it? It's Ross Kinlan in 1975. So this is the algorithm. Choose the best attribute to split the remaining instances with that attribute a decision node. Repeat this process for recursively for each child. Stop when all the instances have the same target attribute value and no longer more attributes. There are no more instances. Something like this. So I'm going to fast forward it a little bit. So there are different concepts of decision tree. We have also entropy. So when we are going to generate the answer for decision tree, we are having expected entropy and information gain from the outcome. So we can also decrease the number of attributes used in a tree by means of pruning. Anong ibig sabihin ng pruning? Ang ibig sabihin ng pruning is tinatanggal natin yung ibang sanga. The other branches of the decision tree are being pruned. So ang ibig sabihin, kung yari gusto mo lang makita yung shallow tree, hindi masyadong malalim. Shallow lang or mababaw lang yung tree. So, pwede natin siyang i-pruning using forward pruning or backward pruning. Or in short, basta puputulin natin yung malalim na part ng decision tree. So, there are what we call pre-pruning. So, we stop adding attributes based on information gain. However, this may be problematic. Why? Sometimes attributes individually do not contribute much to a decision, but combined, they may have significant impact. So, yun lang naman ang problema ng pre-pruning. Kasi sa totoo lang, pag sobrang lalim ng decision tree nyo, ang hirap niyang i-interpret. Sobrang hirap niyang i-interpret. So, ginagawa ng iba, binababawan lang nila yung decision tree or kinokontihan lang nila yung branches. So they use pre-pruning. Ayan. There is also post-pruning. Yung pre-pruning, ang problema nito is maaaring may matanggal ka na importante dun sa isang node, kaya silang dalawa pag pinagsama, mas mataas yung impact nila. Since nag-pre-pruning ka, posibleng hindi mo na yan ma-meet yung ganong requirements. Kasi maaaring ma-pre-prune mo yung kalahati. Tapos kailangan yung another kalahati na yun para sa susunod pa na insights. So mayroong post-pruning. Ayan. Okay. And then there is sub-tree replacement. Something like this. Ayan. Fast forward natin ng konti. So this is how the decision tree is doing. No? So pwede siyang gamitin sa games. Ayan. So ang tawag naman dito is regression tree kasi kung titignan ninyo, yung target is numerical value. So pag yung target is numerical value, that is a regression tree. Ayan. So yung outcome, ang outcome ng decision tree, yung nasa ilalim, yung tinatawag nating leaf, no? Okay, so that's a decision tree. Okay, let me show to you another example, but in a form of weka. So, i-run ko lang yung weka ko. No? So, tandaan niyo bakit ginagamit ko yung weka kasi gusto ko siyang ipakita nang hindi kailangan mag-code. Yung machine learning, hindi mo kailangan mag-code. So, gagamit ka lang ng mga tools such as weka. So, for example, this is weka. No? So, we're going to use a simple data set that is already saved here. Okay, so puntahan natin yung data na yun. I think applications. Okay, kasi excuse me. Yeah. Ito yung weather. Tingnan natin yung data niya. No? Ayan. So ito yung features niya. Outlook, temperature, humidity, windy. Ano yung target niya? Ano yung target niya, class? Hello? Ano yung target niya? Nakikita niyo ba? So dito, we have outlook, temperature, humidity, windy. And the target is play. Play siya. So yung target natin, siya yung magiging outcome. Makakapag-play ba tayo sa labas o hindi? So there are different features na titignan yung decision tree natin. Outlook. Ang outlook, meron siyang sunny, ibig sabihin maaraw, overcast, madaming clouds. And then yung rainy, ibig sabihin, ano siya, umuulan. So usually, pag sunny, maaraw, mainit. Pero may mga overcast din na mainit. Tapos may mga sunny din na mild, hindi naman ganun kainit. Tapos mayroong mga rainy na mga mild siya. So ibig sabihin hindi siya pure. May mga times na umuulan pero mainit ang pakiramdam. Tapos may mga sunny na malamig, May overcast na malamig, may rainy din na malamig. Tapos yung humidity, no? Yung humidity, ano siya? Ano ang humidity? So the humidity is the amount of vapor in the air. So if there is a lot of water vapor in the air, the humidity will be high. The higher the humidity, the wetter it feels outside on the weather reports. So ano siya, parang ang feeling mo malagkit ka, parang ganun. Marami kasing water vapor. Malagkit sa katawan. Ganun siya. No? Ganun yung feeling. Humidity. Mataas yung humidity. Windy is malakas ang hangin at minsan kahit maaraw, malakas ang hangin. So pag may mga ganitong klaseng features, kailangan natin gamitin ang classification para malaman kung makakapaglaro ba tayo or hindi. Ayan. So punta tayo dito sa classify ng weka. Tapos pipiliin ko yung trees at saka J48. Ayan. So hayaan lang natin siya. Then kung mapapansin niyo, nakaselect yung target niya as play. So start natin yung play. Ayan. So ang prediction niya is 50-50, parang ganun. May 7 beses siya na nagkamali siya at may 7 beses din siya na tama siya. 50-50 siya. So 50-50. So hanap tayo ng magandang tree. Siguro itong random forest. Ito medyo maganda siya, no? Okay, so sa predictive analytics, ang tinitingnan natin dito, yung accuracy ng prediction, which is 71%. Ano yung error niya? 28%. So ito yung kanyang confusion matrix. Yung confusion matrix niya, ibig sabihin yan, mapag-zoom. Anyway, zoom. So, let me explain. Ang ibig sabihin na itong 8 yung prediction mo, and 8 din yung totoong 8. Tapos, yung isa, which is yes, napagkamalan mo siyang B. So, nagkaroon ka ng konting error doon. Tama na merong 8 na yes, pero ang totoo niyan, siya mang yes. Ang prediction mo lang is 8 na yes. Okay? Nagkamali ka ng 1 beses. Dito naman, ang prediction mo sa pangalawang row, dalawa lang talaga ay 5 talaga ang no. 5 no, pero akala mo yung 3 doon is yes. At ang correctly na instance na predict mo is 2 lang. 2 lang na no. Therefore, pag pinag-plus mo yung 8 plus 2, the answer is 10. Ito, yan, 10. And 71% ka sa correct mo. Ngayon, yung mali ka sa false positives, 3 and 1, 3 and 1 plus 3 plus 1 is 4. Therefore, that is 28%. Nagkamali ka ng 28%. Okay. Ayan. So that is the decision tree. So we actually can show makikita natin ngayon yung ano niya, yung decision tree na nito. Ayan. Okay. So next example, ito naman, yung sa Python. Okay, so this one, this Python. Dito may ginamit lang akong dataset. So ito yung dataset niya actually. So meron kang agency, Department of Education, Department of Health, Department of Transportation, Department of Agriculture, and Department of Finance. So meron kang budget na ganito. Meron kang expenditure na ganito. Meron kang allocated budget na ganyan. Meron kang debt budget. So yung debt, yung utang na kailangan bayaran. I don't know kung may ganun talaga sa ano, pero then yung target natin, ang target natin is risk. Ibig sabihin, ano yung mas mapokusin natin dito na budgetan. Okay? So makakapag-decide tayo ng kung sino yung babudgetan natin. Ay, hindi ko pala tinapos ito. Okay, so wait lang. Ay, hindi siya tapos. Okay, so ganito na lang muna. Let's have a break, short break, tapos we will continue this one. Let's have first a short break. Okay, so we're back. Okay. Okay. I'm going to skip the first part. Ito yung pagfo-focusan ko muna. Yung nominal weka data natin. So itong nominal weka, Kinuha ko lang siya sa isang website. Teka lang. So, kinuha ko lang siya dito. Tingnan nyo na lang. Pwede nyo rin naman siyang i-download. Yan. So, I will explain to you what happens in this code. First is what we're going to have is the pandas, of course. Yung pandas. Then we need to invoke the decision classifier and export GraphVis. So we need to do this train test split. Okay. And then accuracy score and then GraphVis. So the GraphVis is used to visualize the tree. We will see that later here. And GraphVis yung ginamit dyan. Then yung accuracy, para ma-print natin yung accuracy niya. So yun. Print natin yung accuracy niya, no? Let me just have a divider. So, pangalan nito is Weka precision using weather data set. Wow. Ayan. So, meron tayong divider. So, accuracy score for the accuracy of our classification. Yung train split kasi yung dataset natin. Ito yung dataset natin, ano? Ayan. So, yung dataset natin, meron siyang lang, 14 entries. So, 14 lang yung instances niya. Therefore, kailangan pa natin split yung ito-training natin, yung if-feed natin na facts or label data sa machine natin, sa model natin. And then, yung iba for testing para ma-predict natin yung accuracy. So, in our data set, ilo-load natin siya from CSV file. So, ito yung CSV file on my right side, on the right side. Now, if we will try to understand the data set has text data or textual data. So we can also call this one as categorical data. Why do we call this one categorical data? Because the composition of our data set is almost text-based. So normally we cannot use or we cannot compute text-based data. Therefore, we need to employ a technique called one-hot encoding. So one-hot encoding tries to transform this data to make it in a way numerical. So let me just show to you. So ito yung na-convert niya na data. After one-hot encoding, so this is the one-hot encoding code. Now if I will save this one, so weather underscore data .2 and the PD .2 underscore CSV, whereas weather underscore data Ayan. Weather dito. Tapos pangalanan natin. Weather and COVID. 1N. 1N. So, play natin ulit. Okay. Yes, we are. Okay. Okay. So, refresh natin. So, ito yan, ano? Ito na yung magiging transformation. So, kung mapapansin ninyo, it became numerical using the one-hot encoding. Naging numerical siya. So, dumami din yung ano natin, features natin. So, basically, yun yung ginagawa ng code na ito. This converts the dataset into one-hot encoding. And then, sinave lang natin siya. Okay. So, pag na one-hot encoding na natin siya, pwede na natin siya ditong ilagay sa X and Y natin, our train and testing. So, yung X is yung features without the play. So yung features, yung other remaining attributes na basta wala din yung play. Tapos yung Y, nandun naman yung value nung play natin. So we split and do the training something like dun sa clustering natin. Then we generate the decision tree and we place that in a variable CLF. And then we train. Basically, we train them. We train our model. And then we predict. And then we test the accuracy. So the accuracy will be printed. And the visualization of our tree will be printed. So this, let me run again. So this is the answer, or not necessarily the answer, but this is the visualization. So what will happen is we get only accuracy of 60%. Why does our accuracy just 60%? Because our data is really small or very short. So this is the visualization, and then this is also the rule set. So what happens here is that to understand our tree, if the humidity is high, okay, so we get true or false, we get 4 people or 4 yeses if the humidity is high. If there are four, we can say that there are 4 yes. And then if the outlook is sunny, 3 and 2, meaning it's impure. So the meaning of light orange, it's impure for the no, favoring to the no branch. And then if it is light blue, meaning it's impure also, therefore we need to split them still. Now about if the windy is true, if it is less than 5, kasi di ba ginawa natin siyang 1 and 0. So it's also mixed, and then we get the final answers at the very, very bottom. So in short, decision tree can provide us a prediction of the classification problem. Okay? So this is an example. What? Have you tried this on your computer? Have you tried this one? Do you get the data? Have you gotten the data? So using the link that I provided, okay, what happens there if I added some new codes, you just press refresh, and all of the new codes will be updating your copies. So far, so good. Let me know. Press 1 if you can follow. Okay, so maybe this is the time to answer your doubts. Probably if you have something on your mind that you wanted to understand about decision trees, I can accept questions. Okay, so yung data set na wait lang. Okay, so basically what I had here, what I have here is the data set of the weather nominal from WECA. But actually, I just Googled it out and it so happened that I found because the data set is actually very common. So I believe I can easily find it when I just Google it out in Google search. So lo and behold, I found something and there you go. I just wanted to create a parallel view. Yeah, for the reason that I want to create a parallel view from Weka and Python. So basically, we're doing the same thing with Weka. At the same time, in Python, we can actually do it in a programmatic manner. Parang ganon. So binibigyan ko lang kayo ng comparison and contrast. No? So anyway, so this is the data set. Kasi yung mga data set din kasi kay Weka is very simple. Very simple to understand. Ngayon, meron pa ditong example sa baba, which is a sample from a generated data set. Ibig sabihin, this is not coming from anyone. This is just generated. Using Python, you can automate kasi yung pag-generate ng data. So, not necessarily naghahanap tayo ng data. But, may mga caveats to. Ibig sabihin, hindi dapat to pinapractice yung pagpa-falsificate o pag-generate ng data. For the reason na nag-generate ako ng data kasi meron akong gustong or simpler form. Kasi pagka nagda-download tayo ng data, usually yung mga dina-download nating data, hindi siya naka-simple form. Okay? So ibig sabihin, naka-complex form siya. So nagiging mahirap intindihin yung topic na dinidiscuss ko kapag sobrang complex ng dataset na nakukuha natin sa online, sa internet. So I have here a generated dataset instead. So ito, classification lang siya kung yung tao is for readmission, ika-classify natin siya kung marireadmit siya ulit or pakakawalan na natin siya or hindi na siya marireadmit after admission. So itong problem na to sa second part is about classifying kung yung patient natin sa hospital marireadmission or hindi siya marireadmission based on historical data which we have here. But in fact, the data is actually generated. So, parang nag-create lang tayo ng synthetic data sa hospital. Kasi technically sa hospital naman, may mga children, may mga teenager, there are adults, there are elderly. So basically, meron din silang mga symptoms na sinasabi. Tapos kinukuha din natin yung weight nila, yung BMI nila, yung blood pressure nila, yung heart rate nila. Naka-random lang to. So this portrays how might be the data set that can we generate from a hospital. And at the end of the day, we will try to get the target data. So the target data is actually nakalagay na dito, readmission probably, if I remember. This one. So this is our target. Our target is readmission, yes or no. That's why in our classification, we have readmitted and not readmitted. And so, readmission yung ginamit natin. Readmission yung target natin. Kasi may mga di umano na mga pasyente, according sa data, na bumalik. At ano yung mga condition nila na bumalik? Yung mga bumalik na pasyente, ano yung mga condition nila? Okay. So may readmission na mga nangyari. So parang ang nangyari dito sa dataset natin, may mga ni-records tayo na pasyente tapos na-readmit. So ngayon, using the dataset that we have, we can predict in the future kung ano yung katangian ng mga marireadmit na pasyente. Base pa lang dun sa check-up nila. No? So doon natin mapakikinabangan yung mga tinatawag nating predictive analytics. Napipredict natin yung mga possible na classification or regression dun sa dataset na nakukuha natin sa day-to-day transactions natin. Something like this. So I will play this program and magge-generate muna siya ng data. So ito yung katangian ng dataset natin. Okay, nag-generate siya ng data. So this is asynthetic data, meaning this is not backed up with true data, but this was generated. So we can do that in Python. Yun yung kagandahan ni Python. Para makapag-training tayo or makapag-practice tayo ng machine learning, predictive analytics, classification, and regression. So at the next step, we will try to split. Okay? So we split the data using X and Y. Ang meaning ng X is training. Ang meaning ng X is training data or train data. Ang meaning naman ng Y is test data. Okay? So, meron tayong mapupunta sa X train, X test. Ito pala yung tinatawag natin labeled data. Label data, not necessarily training and testing data. So, this is training data, but this is the label data. Meaning, ito yung mga sagot. Diba? Supervised learning nga eh. So, ito yung sagot. Ito yung nakatag yung classification niya. So, maglo-learn tayo doon. Pag-aaralan siya ng machine natin. Yan yung label data. So, split natin siya, meaning ng 2 is 20% testing data. So, ibig sabihin, kung meron kang 100% na number of data set, 20% nun, kukunin for testing. Hindi natin siya isasama for training kasi magiging bias or overfit yung training natin. So, I will also explain this concept by next time kasi sa clustering, wala tayong ginawang splitting. Kasi walang ganong concept sa clustering. So ito, nag-split tayo ng data. I-explain ko yan by next meeting, yung ibig sabihin ng splitting. Then pag na-split na natin siya, we have a training of X and we also have Y train. And then we have X test and then we also have Y test. So yung X train at saka Y train, gagamitin natin yan dito for our training. Kaya kung mapapansin niyo, pinasok natin siya sa argument na X train at Y train. So yung terminology ng training is fit or fitting. Saan ba nabuo yung fitting na yan? Kasi sa mathematics, pinifit natin siya sa Cartesian plane. So yun yung ibig sabihin ng fit. Kaya finifit natin. So yung decision tree natin, invoke natin siya with a maximum of depth of 3. Ibig sabihin na to, ayaw natin palalimin yung ano natin, yung decision tree natin. Hanggang 3 layers lang siya or 3 nodes of level. Then basically pagkatapos ng training, okay na yung classification natin, natuto na siya. Kailangan lang natin siyang i-plot, no? So magkikreate tayo ng plot dito using the classifier. Ayan. And then ito yung prediction. Ipipaste natin siya sa Y-pred. And then yung Y-pred na yon, gagamitin kasi natin siya later for classification, for accuracy. Pero hindi na yata pinakita yung accuracy natin. So yung Y-pred, ito yung mga predicted niya na galing dito sa Y-test. Ayan. Itong Y-test, this is the actual true value. Then itong X-test, ito yung pagbabanggaan niya ng prediction. Okay? Then, mag-generate siya ngayon ng tree. So ito yung tree na na-generate niya. So, ibig sabihin nito, may mga tao na marireadmit sa baba at may mga tao din na hindi marireadmit. Yan. So, classification siya ng mga taong marireadmit base sa kalagayan nila. Mapipredict natin kung marireadmit sila or hindi. So, this is the decision set, no? Ito yun, no? Pwede nating i-interpret. Ito yung visualization mo. So, ginagamit natin yung decision tree. In short, ginagamit natin yung decision tree to provide a simulated logic, to provide a decision tree that will give us a scientific proof of our insights. Using machine learning, we can provide insights and classify yung mga bagong papasok na data natin. So, for example, may pumasok na bagong data, hindi natin alam yung kanyang classification. We can use this model to know the classification of that new data. Okay, so let's have another example dito sa baba. So ito, gagamitin lang natin yung code natin dito sa taas, pero may bago tayong gagamiting dataset. No? So, I think ang gagamitin kong code itong decision tree using weather dataset. Okay, so ang gagawin ko is, dito sa pinakababa, maglagay lang ako ng text to separate. So what I will call this one is decision tree and breast cancer dataset. Okay. Ayan. So first and foremost, sabi ko nga sa inyo, hindi nyo naman kailangan kabisituin yung code. Minsan, pag may pattern na kayo, you just need to, copy and paste. So first is let's just copy this code. Copy natin to. Then, i-paste natin siya dun sa baba. So this will serve as the libraries that we're going to use for our decision tree and the breast cancer dataset. Of course, we need to get a dataset. That's the first and foremost problem. So I'm just going to copy this code and then I will be editing the code to load the dataset. Basically, the breast cancer dataset is coming from GitHub again, and I will be posting it in our chat box. Ayan. So, kumuha lang ako sa GitHub. Kasi, wala lang, tinatamad lang akong mag-convert. Kasi kung meron ng existing, hindi, leverage na ako doon, di ba? So, ito yung link na nilagay ko sa chat. Ayan, so I'm just basically going to click raw, no? So, ito yung data, by the way. So, yung data na yan siya. Kung mapapansin natin yung data, may mga siya, yung age natin naka-range, yung Nephals post string siya or categorical. Yung tumor size niya parang range din, so kailangan din natin yung i-clean. So yung way natin ng pag-i-clean yan is yung tinatawag nating one-hot encoding. Later gagawin natin siya. Tapos ito yung target niya, by the way, yung class. Reoccurrence events, false recurrence events. Okay, so gano'ng kadami to? It's around 273. Okay, so most of them are categorical, so we need to use one-hot encoding to make it everyone numerical. Okay. So from categorical, we need to transform this one into numerical. So i-click ko yung raw, tapos ayan, i-download ko lang siya, save as. Breast cancer, automatically masasave yan as CSV, ayan. Kung mapapansin nyo, nasa baba, breast cancer. Then, I'm just going to upload it here. Yung CSV file. Ayan. Ayan, nandiyan na yung breast cancer. And then, papalitan ko lang to. No? Breast cancer. Ayan. So, syempre, now this becomes breast cancer or BC. Or sige, breast na lang. Breast cancer. Breast cancer data. Okay. The next, ito na. So, kailangan na natin i-convert yung ibang strings into a one-hot encoding. So ginamit natin dito is yung pd.getDummies. This is a method to do one-hot encoding of the dummy variables. So for the breast cancer, probably I'm going to put there yung mga nandito na hindi numerical. So I consider to, kahit numerical to, hindi siya numerical kasi range siya. Wala namang numerical na may 40-49, di ba? So I still consider that as non-numerical. Therefore, kailangan ko yan i-one-hot encoding. So ilalagay ko dito yung age, of course. Ilalagay ko dito yung age. Tapos, may false pos. May false pos. Then tumor size. Tumor size. What else? In all of the things that are not numerical will be placed in a one-hot encoding. In false this. In false this. Just another one pa. False backups. Yung degmaline siguro yan, Hindi na natin siya ilalagay dyan kasi numerical na siya. 3, 1, 2, 3 yan. So, hindi na. So, yung breast quad. Breast quad. Last two. Irradiate. Last one na pala yun, irradiate. So, yung class, hindi natin siya iwa-one-hot encoding because target class yan. So, hindi natin siya gagananin. Ayan. So, ang nilagay lang natin is columns age, may false pulse, tumor size, in false des. Tama ba yan? In false des, false decaps. Mga medical term siguro to, kaya hindi natin siya medical term yan. So, i-run lang natin muna yung code natin para matignan natin kung may error. Ayan, katulad niya, may error. Breast. Ayan. None of the index age columns. Totoo ba? So, ibig sabihin, sabi niya daw, wala daw yun, hindi na daw i-exist yun. So, check muna natin. Oo, kasi weather data. Okay, so, breast cancer. Okay, then, PDGetDummies. Hindi siya weather data, breast cancer kasi. Ayan. Okay. So, close na natin to. Wala nang problema dito, I guess. Okay, breast cancer. Check natin again. Oops, meron pa. Breast quad, not in index. Breast quad is not included daw. Check natin ulit. Breast quad. Breast quad. Oh, saan yan? Quad. Dapat quad, di ba? Ayan, so gumana na siya, no? Okay, so we're done. We're okay. So let us check. Probably isa-save natin yon, di ba? Katulad ng ginawa ko doon. Ayan, sinave ko siya. So, kunin ko na yung buong code, di ba? Nahiya pa ako eh. Inisa-isa ko pa. Kunin ko na lahat, din edit ko na lang, di ba? Baba tayo. Okay. Ayan. So, breast cancer, yan. Okay na. Convert to categorical. Ayan. Ba't ganyan? Teka lang. Nawala yung save. Okay. Lagyan natin to dito, no? Because we're going to save the outcome of our one-hot encoding. Okay, so we will drop readmission ata yun. Readmission. Class. Okay, so maganda, class na lang yung pangalan. So we will drop class. And then we will also use this one as class. Random stay. Breast cancer 3. Class name, yes. Hindi yata no, yes yun. Ano? Low. Reoccurrence events, false reoccurrence events. Reoccurrence events, false. Dalawa lang ba? O dalawa lang yata, no? False reoccurrence events tsaka reoccurrence events. So, copy natin yan. Lagay natin siya dito sa ating code. At saka reoccurrence events. Okay, so let's run this one. Okay, may error. Class not found in access. Class. Let me just check. Quick check. Ito pala. May mali pa pala. Kaya pala nag-error. Breast cancer. Breast. Pa natin. Could not convert string float 4049. Bakit? I-drop. Dapat madadrop na yun. Ganun. Let me just check the data here. Hindi nag one at encoding. Okay. Ba't hindi ito nag-run? Line 11. Ay, oo, meron yun. Ito yun. Sorry. Ayan, okay na. Ayan, so this is the result. Ito siya. Ay, teka. Breast cancer 3, dapat lalabas yun. Ito. Breast cancer 3. Yan. So, laki ng 3 natin, ano? Sobrang laki, no? So, nandiyan yung ibig sabihin mo pag in-interpret natin siya. So, usually, pag in-interpret nyo lang yan, parang yes or no lang yan, or true or false. So, ibig sabihin, our degree of malignance, siguro, ganun ibig sabihin nun. Yung 132, mapupunta dito sa left side. Tapos yung 58 dito sa right side. Yan, ganun siya. So, saan yung check-checkin? In false des, 24. Ito. In false des, mapupunta yung 24 dito or 26. Then, yung iba, yung 30 or 28, mapupunta dito sa right side. In the end of the day, madidetermine natin kung reoccurrence event siya or false reoccurrence events. So magkakaroon tayo ng decision 3, something like this. So kung ayaw nyo naman ng decision 3, what will happen is you can basically get decision or rules, set rules, no? Yung accuracy niya is 64% lang. So, ang ideal natin na accuracy is 99.9%. Pero kung 80%, okay na rin yun. Pwede na rin yun. Okay? Okay, for your activity, for our remaining time, I would like you to do a decision tree classification for this iris dataset. So, yung target ninyo dito is yung variety. And since all of the values are numerical in nature, you don't need to do the part of the one-hot encoding. No? Hello? You don't need to do this part, yung part na to. So, if your data set doesn't have categorical data with regards to the X or the features, pwede ninyong tanggalin yung one-hot encoding. So ito, pwede nyo siyang tanggalin, yung part na yan. Okay, since yung data natin is numerical in nature. So yung target nyo dito, instead na dito sa iris, saan na ba yung target? Target, ito. Instead na yung class, yung gagamitin nyo dito, you will use the variety. Ayan. You will use variety as the target. Okay? So that is your exercise. Your exercise is to generate the decision tree of this iris dataset. So the dataset link is posted on our chat. Okay. So if you're done, just paste the decision tree, the screenshot of your decision tree for the iris dataset. Okay. Okay, the task is given on our chat box. Okay, so for the remaining time, please demonstrate or create your own decision tree using the dataset, iris dataset that I have posted on our chat box, as well as what you can see on the screen. Okay, so I think everyone, almost everyone are able to do the exercise for the iris dataset. Now, actually, we will get the this one. This is what we call the result set. So I'm going to copy this code and then paste it here, around here. Then change this one into becoming a CLF. Okay, for the reason that what we are using here is CLF. Therefore, that's what I'm going to use as well here. Okay, so let me just, okay, so this is my accuracy, and then this is the tree. Okay. Let me just place this one at the bottom. Okay. Okay, there. And what else? The accuracy, I will place the accuracy below. Okay. All right. So I'm going to show to you one cool feature because I am lazy. I am lazy and there is AI, and you can also do this using Chat GPT. By the way, I'm using Bard. Just wanted to use Bard for this example. So I'm going to copy this one. This is same. This is same as the decision graph tree. Ito yung kaparehas lang ng decision tree graph. Okay. Yung sasabihin ko dito, please interpret the result set for me. Ayan. Okay, so meron na akong result yung aking tree. So hindi na ako mahihilo kaka-analyze, di ba? Right? Ngayon, kung lalakihan ko pa siya, let's say I wanted to, nalitan ko yata siya kanina. Nalitan ko ba siya? Sino ba yun? Ito, nalitan ko siya. Max depth. So if I'm going to remove the max depth, something like that, I will get the whole decision tree, right? This is result set. Now, because this is very plenty, it's hard for me to really analyze this one. This is where AI can help us to understand the decision tree. So, sasabihin ko lang sa kanya, oops. Can you help me interpret this result set? Mas maganda yung kanina, parang malito. Hindi, meron naman pala. Ayan, may explanation naman pala. Kala ko dinescribe niya lang. Can you report to me this result set? Ganun pa rin yung result, yung sagot niya. Okay, so sa inyo na lang yan, kung for you to easily understand the result, just read this one. So the result set is a decision tree, which is a type of machine learning algorithm that can be used to make predictions. In this case, the decision tree is being used to predict whether or not the patient will experience recurrence events after breast cancer treatment. The decision tree is made out of a series of nodes, each of which represents a decision that needs to be made. The first node in the decision tree asks the question, is the patient's tumor size between 10 to 15 milliliters? If the answer is yes, then the patient is more likely to experience recurrence events. If the answer is no, then the patient is less likely to experience recurrence events. Okay, so may mga ganyan siya na tulong sa atin. Okay. By the way, if you don't have BARD, you can use ChatGPT for the result set. Can you try? Can you try it for iris dataset? And then paste niyo yung sinabi ni ChatGPT dito. Hello, how was it? Naga Magagawa niyo ba? I see that Reggie Christian had already used or interpreted the results of the decision tree. We are very lucky today because there is already ChatGPT. Before, it's very tedious to interpret the results of the decision tree because it's very lengthy. Now, because of ChatGPT, we are now easy to interpret the results of our decision tree. Now, what happens before is that if we cannot discuss the decision tree, what we do is we prune the tree. Pinuputol namin siya, pinapaikli namin siya. No? So that's what we are doing. But now, because there are generative models, nakakatulong siya para ma-interpret natin yung decision tree. Okay, so basically that's the demo of decision tree and the lecture that I have discussed about decision tree for this meeting. I hope you've gained knowledge for today's meeting, and we will continue discussing more about supervised learning algorithms, predictive models for our next session. So that's our session for today. Thank you for attending our seventh session. No, seventh session natin ngayon. Thank you very much. So I'll be uploading the recorded session tomorrow. Thank you. So if you have question, you may want to chat me on our Slack group. So I'll be happy to reply as fast as I could. Thank you very much. See you on our next session. Thank you, Bianca. Thank you, Romel. Thank you, Christian. Thank you, Reggie. Thank you, Eileen. Thank you, Nico. Thank you, Ryan. Thank you, Mary Ann. Thank you. Okay.